Good morning, everyone. I hope this session will prove to be fruitful. There are some difficult things, and it's difficult for me to deliver a presentation before a master of this field, our seasoned professor. And after his presentation, of course, it's challenging for me to make a presentation. And I will try my best. And we have cooperated with our president, Kemal Bey, and CTP Boru. In 2015, Turkish Composite Summit is offering this logo. And CTP Pipe and Practices. I'm Ahmet Ünal. Microphone, please. The speaker is supposed to speak close to the microphone, otherwise we won't provide the interpretation service.
İlk etapta oluşan 6 tane kuruluştan
Efendim, konuşmacımızın mikrofona yakın konuşması gerekiyor, yoksa çeviri için duyamıyoruz kendisini.
Grand Pipe, Subor ve Süperlit logoları da altta görmek üzere kolları sıvadılar. İyi ki de böyle bir şekilde bir araya geldiler. Birlikten kuvvet doğar. Her ne kadar birbirlerinin rakipleri de olsa Türkiye'ye katkıda bulunan değerli sanayicilerimizdir. Bir next slide'da. Şimdi ben size kompozit malzemelerin tanımını yapıyorum. Doğaya baktığımız zaman doğa bize diyor ki senin elastiklik modülün yüksekse muhakkak ve muhakkak kopma o zaman düşüktür diyor. Yani şöyle elimizde tuttuğumuz bir manivelayı yani kaldıraçı kullanırsak dayancın yüksek, elastiklik modülün yüksek, o halde kopma o zaman düşük. O halde çağ gelişiyor, bana diyor ki işte 1 + 1 2 etmez o, yani yoksa 1 + 1 2 ediyor tabii. Etmez'in şeyinde, konseptinde diyor ki bize senin hem E modülün yüksek olsun hem de elongation, kopma o zaman yüksek olsun. Yani buna kısaca anlayalım diye elastikiyet diyoruz. Pekala. O halde biz ne yapalım? Human made or man made, yani insan yapımı bir malzeme geliştirelim. Doğaya biraz da karşı çıkalım. Ama doğanın kurallarını bozmadan. Pekala. Karşı çıktığımızda geliştirildiğimiz malzeme kompozit malzemeler diyoruz. Ve çok basit bir tanım var. En az 2 malzemenin arada kimyasal bağ yapmaksızın lakin bir arayüzeyi oluşturarak geliştirdiği yeni malzeme grubu kompozit malzemeler diyoruz. Hocam kompozit malzeme nereden çıktı? Lütfen kendimize bakalım. Tıp fakültesinde bizi ilk girdiğimiz anatomi dersinde, daha sonra fizyoloji dersinde şu şekilde gruplarlar. İnsan yumuşak ve sert dokudan oluşmuştur derler ve yumuşak dokunun E modülünün bütün datalarını verirler.
Unfortunately, we don't hear the speaker because the microphone is not working properly.
Yumuşak dokumuz arasında uyuşumsuz derecede büyük farklar derecesinde elastik özellikler vardır. Ama bizim yükümüzü pekala iskelet sistemimizi taşır. Yani vertebramız, omurgamız, ama buna karşılık bütün suspansiye görevlerimiz, elastik özelliklerimiz, elastikten sonra gelen plastik özelliklerimiz yumuşak dokudur. İşte biz de şimdi buradan hareket ediyoruz. Biz de buradan hareket ediyoruz. Kompozit malzemenin tanımı var. Bir de burada şık bir şey var. Bunu öyle gösteriyoruz. Eğer kompozit olmasaydı bunlar da olmazdı. Mesela şu anda tenis şampiyonası vardı. Tenisçiler bize çok şey borçlu, kompozitçilere. Ondan sonra shuttle'lar, yelken yarışları vardı. Katamaran tekne, kompozitlere çok şey borçlu. Pekala, bunu ben bizim sitenin şeyinden aldım, sayfasından aldım. Yüksek özgül mukavemet. Bakın arkadaşlar, ben de 1976 mezunuyum. 76'da mühendistim, yani diplomam var. 76'da mezun olduğum zaman yaptığım hesaplar, işlerde, kitaplarda vesaire tasarımlarda hep şunu yapardım. Yüksek mukavemet, yüksek mukavemet. Sonra yeni bir kavram çıktı. Bu Amerikalılar geliştirdi bunu. Boşuna geliştirmediler. Bizde hayır, artık bugün yüksek dayanç, yani mukavemet veya yüksek elastiklik modülü istemiyorlar bizden. Ne istiyorlar? Bizden her malzemenin sigmasını, yani elastiklik modülünü ve çekme dayancını kendi rho'suna, yoğunluğuna bölün. Buna spesifik mukavemet, yani özgül mukavemet veya özgül modül diyoruz. İşte bunları yaptığımız zaman yeni tasarım esaslarında birdenbire açık farklı, açık ara siz önde gidiyorsunuz malzememiz. Bunu borucular kullanıyor. Diğer kompozitlerin plastik maddesi kompozitler tamamı kullanıyor. Ve havacılık ve uzay yeni bir kompozitin bir grubu, ama ayrı bir grup bunu kullanıyorlar. Alttakileri gördüğümüz için hiç gerek yok bunlara. Pekala. Bunu niçin verdim size? Bu klasik bir konvansiyonel bilgi ama doğal kompozit, mikro kompozit, makro kompozit mesela klasik bir CTP üretimi bir mikro kompozittir. Fakat mesela bir sacın kaplanması makro kompozittir. CTP boru aynı anda hem mikro hem makro kompozit.
And you may ask the damage analysis to me. The CTP pipe is fragile, but the analysis of CTP pipe, when you look at that, you can have a look at the micro analysis. And also in the micro level, as you do winding, then what we have to consider is the micro and the macro composite analysis and also the damage analysis. So you can look into the breaking points or the elimination. So this is why I have grouped it this way. So the damage analysis is a very large subject in itself. And here I have to also say that I'm a lecturer at the Department of Meteorology and Materials, and of course we work on materials and metals for years, and we do group the composites as well, and in reinforced groups you can have a look at the plastic matrix, and we will see the details later on. Let's have a look at their areas of usage. When we look at the biomedical materials and also the fixators, the external materials, they used to be stainless steel, but now there are other carbon materials used. So, for example, you can look at the cars by Lotus, for example. Without the composites, it wouldn't be possible to manufacture it. The bridges, for example, the Defense of Ministry of the United States of America has those keywords, and the keywords are like clean energy. And in clean energy, we do not maybe exist, but the design material we use, for example, is the composite material on the right-hand side bottom. And here, I used to talk about this before, Reinforced Plastics Journal, by this. This is by them, and the plastics composites are high in amount, and it's around 96%. So the others are shrinking, I should say, the MCCs or CMCs. And also, I can talk about the first time that CTP pipes was used in 1948. For example, the MCC was used in a Volkswagen car in the crane beds. And when it was bombarded during the war, in Berlin, under the laboratories of the universities, they conducted the research. And in 1944, when there was an eruption of production or manufacturing, they put the usage of those into activity, the MCCs. So I can also talk about the sociological information. In between 40 and 1944, the population decreased in Europe because the fertility decreased and also production decreased, except for the war industry. In 1945, there was a boom of birth, because after the war, the birth rate increased dramatically after 45. And after peace, also the production increased in volume. And CTP, for the first time, by the way, as I said before, was used in 1948. And then the usage of it increased along the years. And the USA and the ever increasing usage of composites in its production as we see, it's not linear, but it has increased a lot, and you can see the amounts here as well. And these are the areas of usage for composites, so aerospace or aviation. But I have to say it's important. The composite is significant, but the amount used is not that much. And in the shipping industry, it's heavily used, and transportation as well. So where does the CTP pipes sit here? I have to say that it's construction and chemistry and processing, the CTPs. And looking at all the composites, I can say that it's 25% when you add the construction and chemistry together. It's 25%. And in Europe, the usage of composites is almost the same compared to the USA. You can have a look at the figures and also the increasing figures along the years. And the composite usage can be grouped into hand layup techniques and also the machine molding. And when you look at the hand layup methods, it's a conventional one, we know, and you can see that in periods, in a periodical point of view. For example, it decreased, and spraying also decreased, but fiber winding or BMC or CMC and pultrusion techniques, BMC being the bulk molding compound and CMC sheet molding compound, we see that they have increased. And still, we can say that the main manufacturing technique is filament winding. It's very crucial, and the industry says that yes, we do use it. And we manufacture, and you can see the figures in 2015, 20% is the share of the filament winding, and this is an important figure by itself. And in the world, you can get access to the database. This is the per capita consumption in the world. And these ceramic composites are the hybrid composites, and we should also think about the, of course, combinations. And in France, for example, you can see the usage of composite per capita. In Japan, the automotive is in the foreground, and in North Korea as well. And in our country, I said it could be 2%, but it's not 2. It's not 2 kilograms. I said 2, but the figure is about 0.9 to 1.5. I put it here as 2 to motivate our friends. And the increase rate in between 2015 and 1995, you can see South Korea, Malaysia. Malaysia, they have aviation in particular, and it's 8, the increased rate. The figures here are very realistic. So when was the first manufacturing of CTP pipe? In 1948, and there are some colleagues who helped me to put this picture here. And we prepared the PPT as a group. I'm only the presenter of that. It was used in 1948, and you can see how it was used, and you can see it on our page website. And also we will share the PPT, the PowerPoint presentation with you as well afterwards. And this is another image, the filament winding, and you can have a look at the diameters of the pipes. And this is a picture from Turkey. You can see the Turkish flag, and we are of course proud to see those taking place in our country. And classical filament winding. These are less thick methods, and you have the control, and you can take the polyester material or epoxies, and you can arrange the amount to be used. It may be glass, it may be carbon, and you can do set the filaments and also set the fillers. And these are flexible methods, and filament winding seems to be the best methodology for CTP pipe manufacturing, and you can come up with the sizes you wish and the thickness that you aim for. And this is a very important concept because you can manufacture the size or the type that you wish with the flexibility it provides. And when you look at the diameters, we can see that it's in between 300 millimeters to 4,000 millimeters, and you can see the bar are in between 1 to 40, and the rigidness is 2,500 up to 10,000. And the length is the standard one is 12 to 6, but even if it's a standard, you can come up with the length that you wish. You can cut and operate accordingly, and this is another advantage it provides to you. There's a problem about this slide here, but here you can see in 5 continents, in 59 countries, the CTP pipes manufactured in Turkey are used. So this is a good map that depicts what Turkey has been doing in a very short period of time. And in our country, I think from 1989 on, or maybe from 95 on, we can say in the country around 8,000 kilometers, and abroad around 5,700 kilometers long of CTP pipes were installed, and these are good figures actually. And it's difficult so of course to go against the other manufacturers. This is the copper industry, the aluminum industry. So when you go into the business with CTP, it's difficult for you to express yourself only by these specifications. But now there are standards, and these standards go in Turkey and in other countries, and the state hydraulic works also put this in to their specifications, and you can talk about and see the standards, EN for example, or ASTM and ISO, and the standard used by Europe, and also TSE, and for example in Germany it's Deutsche Industrial one, and 1796 is a very good standard. And the pipe manufacturers say that we guarantee our own quality. For example, it goes by ISO 9001 and 2008, and also there's occupational safety and health standards. You can find all those standards here, and in our case as well, the Turkish Standards Institute (TSE) provide those standards, and the Composite Industrialists Union provided those specifications to us that cover all the standards. And the glass fiber reinforced materials, these are continuous fibers, and they are chopped or trimmed, and the thermoset polyester resins can be used, and also filler materials like silice can be used, and they are very functional. The potable water, irrigation, water waste, rain precipitation, industrial facilities, hydroelectricity, power plants, and energy projects are the areas of use for CTP pipes, and thermoplastics, for example, do disappear in the nature in 1,000 years. And the polyester manufacturers say that our products will be damaged and disappear in 5 years. So it's around 480 years. So this means that we are making good investments for the grandchildren of our grandchildren. And the installations of the pipes, canals are opened up and they are supported by cushioning. And I would like to force you a little bit. In composite, for example, we use the plastics and fibers with high strength. And the reciprocal values are taken into consideration. And if you would like to manufacture pipes that are non-breakable, and assuming that the polyester is strong and stiff, we can say that the pipe itself should be flexible while it is also strong. So for further research, if you would like to manufacture non-fragile pipe, maybe I can come up with ideas like establishing extra layers, maybe for example through winding. So our pipe manufacturers are not only manufacturing pipes, they also do establish manufacture fittings, and they do also manufacture those fittings. So it's like pharmaceutics. To think of the MDs, and these fittings are like the pharmacies or the pharmaceuticals who contribute to the medicine, and they say that they deliver turnkey services. The spare parts, other details, other elements, other fittings. These are all contributing elements, and you can cut them and process on site. Eco-friendly, high corrosion resistance, especially if you are delivering lectures in shipping department. This corrosion subject takes a long time, and I should not bore you with manufacturing figures, but in the ships, the painting is generally related with the parts that remain under the water and that do get covered by moss, and this slows down the ships. And this is why it's important, especially to keep the surface quality here. Doesn't require sacrifice, knots, and this is a very good picture of fitting. The EPDM capture is used here. There are stoppers, and it provides us to be able to rotate it with big radius. And the flexibility is here important, and we can compensate it ourselves. And the earth quality is different. It's more flexible, and these are the deviations and the values. So while installing that pipe, if we have a good photochronometry and a good construction engineer, for example, we can come up with the best optional method. And I should proceed. So what do we do about the conventional pipes? We do excavate and do establish a base, and also do establish a crane system. For example, in the concrete, it's heavy. In steel, it's much heavier. And in the portable system, we do establish the crane system after excavation. But here you can do install the pipes with excavators. So you can install as you excavate. And these are the quality documents we have. It's not easy to acquire all those quality documents. And you can see the activities here. I wouldn't want to take too much of your time. And there's flexibility, and this is another issue for the CTP pipes.
Sıkıştırılması var.
And of course, the selection of fillings are important. And we'll have to decide on the pebble type 1, 2, 3. Of course, the engineering team is very much hands-on with this, and they will help you with it. And CTP pipes are easy to transfer, easy to transport. They're easy to put into the right position. And of course, we don't use the same diameter all the time. We can put them into one another, and it makes life easier in terms of transport. The actual installation, you see it in the colored pictures. The water tightness is ensured. This is a technical picture. Esteemed participants, I would also like to mention that the environmental management is very much about waste management these days, and plastic is deemed toxic by some users, but we need to make clear that it's neither toxic or non-toxic, but thermoset manufacturers need to be aware that the wastes out of manufacturing are recycled and used as filling material. Therefore, I think one of the arguments that we need to use is to mention that we are neutral to the environment in terms of the waste that we produce. Excavators are used for digging and trenching. You can see the picture very clearly here. The bedding is there. Some nice pictures as to how the PDM rubber is used for water tightness. Installation is very easy. A frame is established, and by way of 3-point bending, we ensure that the pipes aren't broken or harmed in any way, and installation is made in uniform manner. If you can ensure that the bedding is nice and clear, there will be no breakages. Uniform is the word. Some more nice pictures. The filling tightened, and pillar by pillar you see the details in the photos. Filling activities for CTP pipes. And of course, the site controls are undertaken by expert companies. And of course, larger diameter pipes are easier to work with. Natural soil or artificial surfaces need to be taken into consideration in terms of the filling process. Another detail in terms of the technical properties. The pipes are cut by way of spiral engines. Some photos from the Ankara drinking water project, from the Beşiktaş wastewater collector. This was a project that caused a lot of trouble in terms of the local residents. Power plants. We call them pipe, but we actually need to use internal pressure vessel as the right terminology, is the correct terminology. This is the Syria irrigation project, some tank applications. And this is the last one. What does this show us? You can be rest assured that this material can be used, say, down to minus 40 Celsius. So life goes on, and we'll continue doing what we need to do. Thank you very much for your attention.
Sayın Genel Sekreterim, çok güzel bir şey geliyor.
Esteemed General Secretary, I just have a quotation. One more thing to share. CTP pipe usage is a habit. Habits are like leaking gas. First you can't quite feel it, and then you can't get rid of it. One more.
Hemen bitiriyoruz. CTP
pipe is more than what it seems, like molars or premolars. You only feel that it's not there when it's not there.